Hello everybody, am I audible? Let me know that am I audible or not. Okay, so I think my voice is very clear, and do one thing guys, do one thing that just use only one group. Okay, use only one group. So I think if all of you come to the thermo solutions wala telegram wala group, then that will be good for us. Okay, actually good for me. Because if you masses on both the groups, I have to open both the groups for your queries. So just masses on the thermo solution only. Okay, I just open your chat. I just open your chat of thermo solutions wala group on the telegram, and I'll you can say I'll answer to the message which I'm getting in the thermo solutions wala group. Okay, so if anybody is not joined yet, then I think link is given to you on the previous wala group. You can join the next group from that link directly, right? Hanji. Okay, so today will be my, you can say, the lecture number 1, and it's solution thermodynamics guys, right? It's solution thermodynamics. So welcome in the solution thermodynamics, and it's lecture number 1, and I hope that you guys are doing very well. You have completed the subjects with me, like the IPC, fluid mechanics, and the chemical technology, and this is my 4th subject guys. So successfully we completed some good, you can say, the vast subject actually, like IPC and fluid mechanics, right? In the same way we will complete the solution thermodynamics also, right? So I hope that you enjoyed the class with me, and now can we start now guys? So I hope that you guys joined the group. Okay, now so कौन कौन है अभी online? Good evening Anushka, Kia, Abhijit, Krunya, everybody. Good evening all of you. So guys, solution thermodynamics. So as you know that in specifically in the chemical engineering, your thermodynamics is divided into the 2 parts. Okay, divided into the 2 parts actually. So first part, I think you already did that part. First part is your classical thermodynamics, right? Classical thermodynamics. So this part you already done, as I know. ठीक है, जितना मुझे पता है. If is there any change, you can tell me. Good evening Maina. And second is your solution thermodynamics guys. ठीक है, solution thermodynamics. Okay, this classical thermodynamics having the weightage of 4 marks. ठीक है, and solution thermodynamics having the 5 to 6 marks. Classical thermodynamics is, you can say, the common part for the chemical engineering people and the mechanical engineering people, right? Solution thermo is the different kind of thermodynamics. Whatever you studied in the classical thermodynamics, maybe in the whole context, solution thermodynamics will be have different kind of taste, I'll say. The explanation will be different kind of, right? Solution thermodynamics is, you can say, kind of a chemistry wala thermodynamics, right? So this let's see that what is the solution thermodynamics and all that. We will see it. Okay, we will see it. So this is an overview actually. So I hope that you have done the classical thermodynamics. Hanji boliye ek baar, because I need some information from the classical thermodynamics also. So before that, just let me know that you guys have completed this classical thermodynamics, in which you studied the 0th law, 1st law, 2nd law, and all that. Hanji boliye, बोलिएगा. Okay, great. Yeah, so, actually, my son health is not good today. That's why I got late. Otherwise, we will start the class as the timetable is saying at 5 o'clock. But my son health is not good today, so मैं अभी आया just इसलिए थोड़ा सा late हो गए हम. ठीक है? Sorry for the inconvenience, guys. Okay. As you know that my first class will be of why we study this particular subject. Okay, what will be the context, in what context we will study this, how this subject, particular this subject will help us in the chemical engineering career. So this is what basically we will do in the first class. So I have the 4 points actually, and that will tell you that why you have to study solution thermodynamics. Why only classical thermodynamics is not sufficient for us. Okay. So if we will talk about the first point, what is the first point, guys? See, as you know that in the chemical engineering industries, most of the industrial processes are the separation processes actually. Okay, and we have to deal with the mixtures, with the real mixtures, with real solutions like that. So first point is to predict how real mixtures behaves, right? So we will take the help from the ideal mixtures, that how the ideal mixtures behaves. Based upon that, we will try to understand that how the real mixture behaves, how the behavior of the real mixture is, how much far from the ideality. Okay, so first point is to predict how real mixture behaves. So industrial systems are rarely pure, guys. Okay, so as I already told you, the ideality is nothing. It is only the, you can say, only the reference, only the benchmark we set, so that we can have the reference level. We can have one thing that is, you can say, comparable. So thermodynamics is basically helps understand deviation from the ideality. Second is to design and optimize separation processes. As you know that we have distillation process, extraction process, absorption process. There are multiple separation processes are there in the chemical industry, and all these are depend upon the equilibrium. There are multiple phases involved, so phase equilibrium will be important for us. Okay, so all depends upon the phase equilibrium and activity fugacity models. So these are depend upon the, these are explained by the these activity and fugacity models, right? What separation processes. Third one is if there is a multiple phase, then there will be a there must be a question of equilibrium. So to calculate the equilibrium compositions, right, essentially for the reactors, especially for the ammonia, syngases, all the refinery processes. Fourth point is to determine the energy requirement and the efficiencies, right? So the energy involved in the processes like enthalpy, the equation of states, different equation of states, and the residual properties and all that. So solution thermodynamics is basically, you can say in one line, if I'll say in one line, then it will help you to understand to optimize, to determine energy requirement of the separation processes. So for that purpose, we need to understand the phase equilibria, how the equilibrium is, you can say, shifted and all that things. Okay, so there is no need to write all these things. Okay, now tell me. Now we will start our solution thermodynamics. So I will start it from the basics, and whatever the informations I required from the classical thermodynamics, I will put here, but in very short. Okay, so we will not explain it in the detail, because you already studied it from the in the classical part, right? So guys, if we'll talk about the solution thermodynamics, in the solution thermodynamics, we will deal with the free energy actually. We will deal with the free energy. Okay. Now you will say, sir, what is this meaning of free energy? Actually, we have the multiple types of the energy. We have the multiple types of the energy, in which we studied a small part, free energy. Free energy is basically of two types of energy. One is your Gibbs. I hope that you heard this name, Gibbs free energy. Gibbs free energy. And second free energy is Helmholtz free energy. These are the name of free energy. Our main discussion in the BTech level is Gibbs free energy. Our total, you can say, our most, you can say, our discussion will related. My most of the discussion is will be the related to Gibbs free energy. Is it clear to you? Okay. If we will talk about the Gibbs free energy, then remember one short point that Gibbs free energy is basically defined at the constant temperature and pressure. Okay, and Helmholtz free energy is calculated or defined at the constant temperature and volume. My major discussion will be of Gibbs free energy. Around the Gibbs free energy, we will discuss the things. We will define the even reactions, chemical reactions from the Gibbs free energy. Is it clear to you? Okay. Hanji. So if we will talk about the Gibbs free energy, guys, then there is a question in our mind that what definition wise, what is my Gibbs free energy? Okay. So if you have any system, I hope that you are aware about the system and surrounding. Okay, you are aware about the system and surrounding. So if is there any issue, you can tell me. ठीक है, बता दो मुझे कि explain करने की requirement है क्या system, surrounding and universe को. Otherwise I will explain it, और नहीं तो मैं फिर आगे चलता हूँ. हाँ जी. So we have the system. A system is nothing but that particular thing which I want to study. ठीक है, which I want to study. That is system. That is only the system. And I want some work from the system. I want some work from the system. Is it clear to you? So Gibbs free energy is nothing but it is a total energy available in any system to do the useful work. So if we will write the definition, then it is the total energy available to any system for useful work. This is the definition of the Gibbs free energy. Very simple definition. Further we will going into the depth of the Gibbs free energy. ठीक है? I hope you all guys are aware about the system, surrounding and all that. हाँ जी बोलो, बोलिएगा. बोलिए, are you guys aware about the system and surrounding? Okay. ठीक है, लिखिएगा. Okay, right? हाँ जी. Okay, now as you know that in the 9th class, when we just step into the physics class, then very first chapter will be the unit and dimensions, and in which the first lecture we will study the fundamental units, derived units, these kind of things we will basically discuss. Likewise, in the solution thermodynamics, we will study the properties. We will talk about the properties. Okay, we will talk about the properties, because to define any system we need the properties. Okay, so in which in the properties, first will be my fundamental properties. First you should know about the fundamental properties. Fundamental properties. I hope that in the classical thermodynamics you are aware about the extensive, intensive properties, what is the definition of the properties and all that, right? fundamental properties. The definition will be the same as we studied the definition of the fundamental units. Simple. Fundamentals, what is the meaning of fundamental? Fundamental means very basic, at the cell level, at very basic. मतलब कि if we break anything and if we reached it to the very small, very smallest, you can say unit, then that will be the fundamental thing. Like for our body, cell will be the fundamental thing. Okay? Okay, so fundamental property is what? Fundamental property is nothing but it is the property which can measure directly without any help of the each other. They will not take any other help. Okay? So there is no requirement of any other calculations. There are these are the you can say sufficient to calculate its value. So what are the fundamental properties? These properties which can measure directly without any help of other property. This is the basic definition of the fundamental property, right? Is it clear to you? Okay. So second definition, you can see that these properties are independent on each other. Right? These properties are independent on each other. So there is no lena dena of each other. Okay? Is it clear to you? Right? So now the question in our mind will be, what are those properties? What are those properties? So my first property will be the temperature. Okay, so what is the temperature? Temperature is nothing but it is the thermal potential responsible for heat transfer. Temperature is what? Temperature is nothing but it is the thermal potential responsible for the heat transfer, right? So temperature will be my first fundamental property. Second will be my pressure. Right? Okay, what are the pressure? What is the pressure? So we studied very in detail in the fluid mechanics that it is the momentum transfer. It is the momentum transfer by molecules on the wall of container. Right? This is my second fundamental property. Third will be my volume. Volume is nothing but it is a 3D space. Volume will be my 3D space. Fourth will be my entropy. It is denoted by the S. Okay? Fifth will be my internal energy. It is denoted by the U. Sixth will be my free energy. In which we will discuss the Helmholtz and Gibbs free energy. And seventh will be my composition. So also in the physics there are 7 fundamental units. Okay, temperature, pressure, volume, current, luminous intensity, composition, right? Like that. And in the thermodynamic, if we'll talk about the properties, here also 7 properties are the fundamental properties: temperature, pressure, volume, entropy, internal energy, free energy and compositions. Clear है? हाँ जी बोलिए. लिखिए एंड बताइए मुझे. इज इट क्लियर टू यू? ओके. Good. Okay, guys. So now let's talk about some classical thermodynamics things. So I hope that all of you are aware about the zeroth law. So can anybody tell me that what is the zeroth law? What is the represent the zeroth law? Zeroth law. Zeroth law. So zeroth law will be basically is about the thermal equilibrium, है ना? It is about the thermal equilibrium. Okay? हाँ जी. First law of thermodynamics. First law of thermodynamics is related to what? Can anybody tell me without the page पलटिंग? पेज नहीं पलटना. कभी पेज पलट रहे हो? बताओ. What is the first law of thermodynamics? What is the principle of the first law of thermodynamics? What is the basically explained by the first law of thermodynamics? Can anybody tell me? बोलिए. क्वांटिटेटिव नहीं, किस पे बेस्ड है? फर्स्ट लॉ ऑफ थर्मोडायनामिक्स इज बेस्ड ऑन व्हाट? Great, conservation of energy, right? So it is first law of thermodynamics is conservation of energy. Conservation of energy. ठीक है, great, right? Second law is about. Second law of thermodynamics is about. Great, very good. Karunya, Devash, Anushka, Kia, or everybody. Yeah, right answer. Second law of thermodynamics is related to what? Second law of thermodynamics is related to what? I'm waiting for your answer. See, मैं अभी के लिए I just want to actually I think you have studied the classical thermodynamics from other teacher, so I don't know that how much you know actually ना, इसलिए मैं थोड़ा सा पीछे वाली की जो चीजें हैं उसके बारे में बात करूंगा. ठीक है, थोड़ा सा मुझे आइडिया लग जाए. दैट्स या यू आर अवेयर अबाउट द बेसिक थिंग्स. ओके, आई नो दैट you know the superb thing of classical thermodynamics. You know better than me. Out of that matter, I just want to know some small basic things which I require in the solution thermodynamics. Actually, a second law of thermodynamics is not related to the entropy. Second law of thermodynamics is basically related to the direction of the heat transfer. It is basically direction of the heat transfer. That always heat will be transferred from high potential to the low potential. ठीक है, I think in the second law you studied the two kind of statement, है ना? कुछ याद है? Planck's and Clausius statement kind of thing. I hope you remember, right? In which you studied the refrigeration cycle and heat engine and all that. So second law of thermodynamics is related to the direction of the heat transfer. Okay, that heat is always transferred, naturally it is transferred from the high potential to the lower potentials, right? So these are the third law you studied in the classical thermodynamics. Okay, is it clear to you? Now we will deal with the third law of the thermodynamics. Third law of thermodynamics. So the third law of the thermodynamics, we basically discussed about the entropy, है ना? We discussed about the entropies. So first of all, let's see the definition of the third law of the thermodynamics. After that, we will discuss this. ठीक है? So that एप्लीकेशन ऑफ सेकंड लॉ वाला बेटा, वो एप्लीकेशन में जो आपने रेफ्रिजरेशन हीट इंजन पढ़ा है, अब उसको मैं कैसे बेटा अभी रिवाइज करवा सकता हूँ? बिकॉज द सोल्यूशन थर्मोडायनेमिक्स इज टोटली डिफरेंट फ्रॉम द क्लासिकल थर्मोडायनेमिक्स. इट इज टोटली डिफरेंट अपॉन द different from the solution thermodynamics. ठीक है, I can tell you some small things but I cannot revise it in detail actually, है ना? Otherwise our solution thermo will be on the backstep. If you have any problem you can ask me, you can message me. ठीक है, I will tell you, but in detail we cannot discuss here. So third law of thermodynamics is what? So let's understand first the definition. After that I will discuss you that what I will discuss with you what is the third law of the thermodynamics. Very simple. At absolute zero temperature, the entropy of any component will be at its minimum value. So I hope that you guys are aware about the entropy. Entropy means the randomness, है ना? Entropy means randomness of the molecules, है ना? Randomness of the molecules, right? So like you have something, you can say if you have something, any object, and if you suddenly drop it, its entropy increases, right? Means the randomness of the molecules are increases. And kinetic theory of gases says that when you increase the temperature, your randomness of the molecules is basically increases. यहाँ से आता है ये सब. This is the back story of the entropy. Kinetic theory of gases says that if you increase the temperature, its randomness increases. It means that randomness, or you can say entropy, is related to the temperature. Is it clear to you? So at absolute zero temperature, what is the absolute zero temperature? Can anybody tell me that what is the absolute zero temperature? So if you decreases the temperature, then the randomness will be slowly decreases. You decrease the temperature, randomness will be decreases. You decrease the temperature, randomness will be decreases. It means at very low temperature, the randomness between the molecules will be low. So third law says that at absolute zero temperature, the randomness of the molecules is basically at its minimum value, or you can say its entropy of the at that component will be its minimum, or you can say it is nearly equal to zero. It is nearly equal to zero. Is it clear to you? Yeah, great, Meena. Very good. 0 Kelvin is the absolute zero temperature, right? Absolute zero temperature is 0 Kelvin. It is 0 Kelvin. Okay? It is minus 273.15 degrees Celsius. So, right? So at 0 Kelvin temperature, the molecules is about to cease. Molecule is seized, guys. Molecules is not about to, you can say, move anywhere. This is that temperature. So if I will talk about the perfectly crystal structure. Perfectly crystal structure means that crystal structure molecules is you can say is having the zero motion. There is no even negligible motion. So for the perfectly structure, my entropy will be zero. Entropy is related to the randomness, and randomness is related to the temperature. If your temperature is nowhere, the temperature is 0 Kelvin, the randomness is no. There is no randomness in the molecules. There is no motion of the molecules, right? So at that state, you can say the entropy will be zero. At that state, you can say that entropy will be zero. Hanji, correct? I hope that you note it down. Hanji. Okay, so next. So if we will discuss about that, what is this entropy change? What is basically the entropy change? So just understand it very seriously. Entropy change is basically your entropy generation entropy generation plus entropy transfer. Entropy transfer. Okay. It is quite difficult to calculate the absolute value of the entropy, because it is difficult to calculate the randomness of the molecules. Its name is also randomness. Randomness means things are random, right? So entropy is related to the randomness. So it is very difficult to calculate the absolute value of the entropy. That's why we calculate the entropy change. That will be easier for us. And that entropy change is basically the entropy generation plus entropy transfer. That is entropy generation is equal to entropy generation plus entropy transfer. Okay. Now let's discuss all these two terms. Entropy generation. Entropy generation, its name suggested that it is the entropy generated. This entropy came into the system due to some generation. So this is always be positive. This is always be positive. Is it clear to you? This is always be positive. हाँ जी बोलो, समझ में आ रही मेरी बात? And this is actually defined for the irreversible process. This is defined for the irreversible process. Okay. Next we will discuss about the processes. Entropy transfer. Entropy transfer can be positive and it can be negative. So it is the actually entropy transfer. If let's suppose this pan is transferring some entropy from this pan is transferring some entropy to this system, then its entropy decreases, so the sign will be negative. And if any object surrounding it, or you can say the surrounding of this is my system, this is my surrounding, if surrounding is transferring the entropy to my system, then its entropy increases, then it will be positive. So entropy transfer will be positive or negative. Okay. So the change in the entropy of any system is due to the two terms. First is the entropy generation and second will be the entropy transfer. Entropy generation will always be positive and it is due to if the process is irreversible. If the process is irreversible. Is it clear to you? Okay. Entropy transfer will be positive or negative. It depends that surrounding is transferring entropy or it is extracting the entropy. I hope that this is clear to you. Boliye. Haan ji bolo. I hope that this is clear to you. Okay. Now let's discuss the processes. That what are the processes? So you are aware about the process, but I have to discuss these things also. It may be that if you are not aware about it, then it will be problematic for me. So next, just put the heading process. So very simple. I hope that you have studied in the classical. First will be, let's suppose, irreversible process. Irreversible process. Very simple, as its name suggested that this is the thermodynamic process. It is the thermodynamic process which is unidirectional. Which is unidirectional. Which is unidirectional. Means the direction is only in single direction. It has single direction. Is it clear to you? Unidirectional. Like very simple examples like aging. Our age is only in the forward direction. है ना? Like I'm 32, you are 20, 21, 22, 23. I think it is not possible to next year, if you are this year, if you have 20 years old, then next year you will be 19. I think this is not possible, right? Aging, corrosion. This is also single direction process. Combustion, right? These are the basically irreversible processes. Second will be the reversible process. Second will be the reversible process. what is the reversible process? You both the direction है ना, it has both the direction, it has the both the direction, means it can move in forward, it can move in the backward also. I hope that this is clear to you. So it is in the both the direction and it is leaving no other effect. This is important, right? If somebody is going from this point to this point, and if it is coming towards the initial point, condition is that there will be no any harm. Let's suppose that somebody is going, let's suppose somebody is going in this direction, and let's suppose there is a plant. Okay, I'm giving you a very basic example. Let's suppose here is a plant, he is going in this direction, and when it is when he is coming towards the initial point, he broke that point, he broke that plant, actually he destroyed this plant and reached to this initial point, you know? So then we cannot say this is the reversible process. Why? Because that it leaves some other effect also. So reversible means exactly it follows the same path without leaving any other effect, okay? So you can say, what are the examples? Like stretching of spring, within elastic limit, because if you are beyond the elastic limit, then the spring cannot regain its original shape. Third will be my spontaneous process. What is a spontaneous process? Nothing, but you can say it is the natural occurring process, right? It is the natural occurring. And see, in the nature every process is irreversible, okay? It is natural occurring and irreversible in nature. So if you will see, whatever the natural processes are, that will be the, you can say, irreversible processes. So natural processes are, you can say, spontaneous processes. Okay? Hanji, is it clear to you? Is it clear to you guys? Correct? Okay. So these are your different kind of process: reversible, irreversible, and the spontaneous, right? So whatever we discussed here, that this is the irreversible process. So this is, I hope that you have now idea about the irreversible process. So entropy generation always will be due to the irreversible process, right? And when we discuss the entropy further, you will understand this point very clearly. Okay, now. So I think in the mass transfer also you studied some potential kind of word, you know, chemical potentials in this and that, like that. So here also we have a potential that is called thermodynamic potential. That is called thermodynamic potential. So let's put the heading thermodynamic potential. Thermodynamic potential. Okay. So as you know that potential is something that is you can say this is a kind of a driving force for any process. So specifically in the thermodynamics, what is the thermodynamic potential? So if I'll tell you the basic information about this, then first of all, it is a scalar quantity. It is a scalar quantity, guys, right? Thermodynamic potential is a scalar quantity. Okay? Why we use this thermodynamic potential? It is used to represent the represent the thermodynamic state of a system. Thermodynamic state of a system. Okay, tell me, I forgot to ask you, you guys have done the part equation of state in the classical thermodynamics? Equation of states, there are van der Waals equations and all that, viral equation of states, where general discussion will be there or not? So we should if you are not aware about it, then we should discuss it. So let me know if you are aware about the equation of states. Okay, okay, we will discuss it. Okay, so it is scalar quantity, and it is the what is the use? It is used to represent the thermodynamic state of a system. Okay. Now, if I will tell you by taking an example of the thermodynamic potential, then one thermodynamic potential is the internal energy. Okay, internal energy. Is it clear to you? So you can say our main thermodynamic potential that has physical interpretation is internal energy. Is internal energy. Okay, is it clear to you? Now the question is, what is this internal energy? How we define this internal energy of a system? So what is it? Simply just understand it. I will explain it in detail also. Internal energy is nothing but it is the energy of configuration. It is the energy of configuration of given system of conservative force. Is it clear to you? With respect to a defined set of reference. Don't worry, I will tell you the meaning. I don't know you are aware about it or not. This is very basic. In the 11th class, we studied the types of the forces, in which we studied the types of forces which are conservative and non-conservative. Okay? Conservative and non-conservative. Potential energy is always potential. The word that is called potential. Potential energy is basically always defined for the conservative forces. Okay? I will make you understand very clearly what I'm telling you guys. That is, this word came from thermodynamic potential. Where forces are conservative, no need to write it, just understand. Forces are conservative forces and non-conservative forces. Conservative forces are those forces which basically having capability to store the energy. And you can say there will be no energy loss. And conservative forces is basically path independent. What I'm saying, see, Let's suppose this is my any spring, and if I'm applying some force into it, or by applying this force, what I'm doing, I'm doing some work done on this spring. I compress this spring up to this length. This is in the compressed form now. So what is the energy in this spring? It is the potential energy of the spring. Okay, how to check it? Just put some small ball here and just leave the spring. The spring will release suddenly and it will give kinetic energy to that ball, right? So this spring force is basically kind of conservative force. So the work done by the conservative force is always stored, and that stored work done is called the potential energy, right? And the work done by the conservative forces is independent on path. It is not dependent upon the path. You are going from here to here, or if you are going from here to here, the work done will be same. Is it clear to you? Okay? Like the gravity force. Gravity force is a conservative type of force. If a ball is you are doing the gravity is doing work from here to here, or here to here, or here to here, the work done will be the same. But in the non-conservative type of forces, work done will be depend upon the path. Sir, give me some example like friction force. Energy will be lost here, right? And if you can say following some different path, you will get the different kind of work done. If you will, as you know that friction force is path dependent force. If you are going here to here, and if you are going here to here, so if you follow path 1 or if you follow path 2, you will find the different kind of friction force. So you will find the different kind of work done. So conservative forces, work done by the conservative forces is always the, you can say, potential. That's why it is the word came, potential. Okay? So this is only for your information. This is only for your knowledge. Okay? Nothing else. Is it clear to you? So it is nothing. What is the thermodynamic potential? Thermodynamic potential is basically my you can say kind of the internal energy. Okay? It is a thermodynamic potential. Okay? Is it clear to you? So if I will tell you about the examples of the thermodynamic potential, what are the examples of the thermodynamic potentials? Examples of the thermodynamic potential. And we have to discuss all those potentials, right? The first example which we already discussed, that is my internal energy. Internal energy. It is denoted by the U. Second will be my enthalpy. Okay, it is denoted by H. Third will be my Gibbs free energy. Gibbs free energy. It is denoted by the G. Fourth, Helmholtz free energy. It is denoted by the capital A. Okay. Fifth is the grand potential. Grand potential. One by one we will discuss this. So fifth will be having no use from our gate point of view, but there will be discussion of all these fourth type of energy. Okay. You will correct it in the cap. Just see the just write the capital H. All these are symbols are in the capital letter. Internal energy, enthalpy, Gibbs free energy, Helmholtz free energy, and grand potentials. Okay. So these H, U, A, G, these are my important discussion in the solution thermodynamics. Okay. Okay. Thank you, Kia, for sharing these topics. Okay, now I have the idea, definition of system, types of thermodynamics properties, path and point function, temperature, measuring scale, gives phase rule. Okay, heat and work, interpretations, first law, second law, concept of entropy, properties of pure substance, mixture of gases. ठीक है, okay. Okay, so these are these are the 5 types of the thermodynamic potentials. So we will discuss these thermodynamic potentials. ठीक है, can we move forward now? Can we move forward now, guys? Can we move forward now? जल्दी बोलिए. बोलो. Okay, great. चलिए, so my first discussion will be of internal energy. ठीक है, wherever you face any difficulty, just tell me, guys. ठीक है, just tell me, just put the heading internal energy. Internal energy denoted by the U, denoted by the U. ठीक है, internal energy concept is given by the first law of thermodynamics. I hope you know that. ठीक है, I hope you know that internal energy concept is given by the first law of the thermodynamics. So here also we just explain this internal energy with the help of the first law. So we know that internal energy is totally temperature dependent function. It is the temperature dependent term. Is it clear to you? Okay, see, so let's suppose I have a cylinder piston assembly. I have a cylinder piston assembly. So this is my piston, and let's suppose some gas is there in this cylinder, and I'm giving heat to the system. Okay, so this is my system actually. So these are my system boundaries, and this is my system, and rest is my surrounding. ठीक है, rest is my surrounding. Let's suppose Q amount of heat I'm giving to this system. ठीक है, Q amount of heat I'm giving to this system. By absorbing this heat, you can say this gas is expanding and the piston is basically moved in this direction. So if this piston is moving in this direction, means I'm getting some work. I'm getting some work. Let's suppose W. Let's suppose W. I'm getting W work. ठीक है. Okay, so Q amount of energy you are giving to the system, out of which you are getting W. W is also work, is also energy. This much of, let's suppose, 100 joule energy you are doing. You can say giving to the system, and you are getting the 40 joule of the work. Now, where this 60 joule is come? Where this still 60 joule is going? This is going into the internal energy of the system. So the internal energy of the system is basically changed by the 60 joule. It is changed by the 60 joule. I hope that this is clear to you. So this is W plus U. This is W plus U, right? So what is the Q? Q is nothing but it is the heat given to the system. Given to the system. What is W? W is the work done by the system. Work done by the system. And what is the U? U is the change in energy. Change in the energy of the system. But in what context we have to define this equation? In terms of the internal energy. So we are you can say interested in only in the change. So let's you can say write this equation in terms of the change. So du, which is du means change in the energy, change in the energy of the system. Du is equal to, this is del Q minus del W. Okay, this is basically change in internal energy. So always we concern with the change in the internal energy. Okay, because to calculate the absolute value of internal energy is kind of a microscopic thing, right? And this is the heat given to the system actually. Okay, and this is the work done by the system. Is it clear to you? So this is my internal energy. In the classical thermodynamics, you have studied the internal energy in very detail, and you also aware about the enthalpy also. Here the discussion will be, most of the discussion will be related to the Gibbs free energy. Okay, Hanji. So this is done. Now second will be enthalpy. It is denoted by the H. What is the H? H is equal to U plus PV. H is equal to U plus PV. Okay. Anji, clear? So if I write this equation in the differential form, in the change form, then I can say it is my del H is equal to, चलिए वो फिर आगे करेंगे, ठीक है, बाद में डिस्कस, अभी सिंपल चीजें डिस्कस कर लेते हैं. H is equal to U plus PV. Okay, so how we define the U, internal energy? This is the total energy required to create a system, है ना? It is required to create a system. Is it clear to you? So it is the total energy required to create a system. Create a system from nowhere. Don't write all these things. What things? Just I will explain some detail to you. Just don't write it, right? This is only for information. See, internal energy is a very big term. Internal energy is a very big term. This internal energy contains two types of energy. One is the kinetic energy and another is the potential energy. Okay, you know that kinetic energy is due to the motion and potential energy is due to the configuration. Is it clear to you? Let's suppose there are random molecules are there and I want to make a system of it. So I have to do some energy to make the system. Let's suppose these are my four corners and I want to make this system, and there are four molecules are randomly distributed over the space. So I move this molecule here, I move this molecule here, and move this molecule here. So I make this system. Is it clear to you? Means I just you can say change the configuration of a system. So basically you can say store some potential energy into it. Okay, and if these are if the gas molecules are there, so there, due to their random motion, due to their vibrational motion, some kinetic energy is there. Addition of these two energy is basically your internal energy of the system. That's why we call that it is a total energy required to create a system from nowhere. Nowhere means molecules are randomly distributed. We pick those molecules and we do the work done against it and store some energy. I hope that you have some picture in your mind. That's what I'm trying to say. Is it clear to you? Okay, PV is basically related to, work done by the system, for its existence. Okay, for its existence. So what is this? Just very simple. Let's suppose I make this system. Okay, now these two molecules are repelling each other, but now this system is in the stable condition. Now this system is applying the, you can say the the system is basically applying, or you can say doing the work done against these forces to remain in this form. This is related to this PV. Okay, these are only definitions. There is no use actually for solving the questions. Okay, but wherever it required, I will tell you in the detail. So H is equal to U plus PV. U is nothing. It has a total energy required to create a system from nowhere. I will tell you the detail also, and I will tell you the PV also. This is the enthalpy. So just remember that enthalpy is you can say, just remember it, right? Definition wise, just remember it. Enthalpy is nothing but it is the maximum work. It is the maximum work. It is the maximum work. Take. Next, third is my Helmholtz energy. Helmholtz free energy. It is denoted by the capital A. It is denoted by the capital A. Okay? Clear? Okay. Helmholtz free energy is basically defined for the constant temperature and volume. For constant temperature and volume. Okay? These quantities are constant here. Okay. What is this called? This is called maximum available work. This is called maximum available work. What is this? See, it is A is equal to U minus Ts. Okay? A is equal to U minus Ts. Okay? So what is U? As you know that it is a total energy. It is the total energy which is required to create the system. Required to create the system. And what is the Ts? What is the Ts? Ts is heat received by the system from its surrounding. From its surrounding. This is nothing but is a Helmholtz free energy. Clear? Boliye. Can we move forward? Fourth will be your Gibbs free energy. Fourth will be your Gibbs free energy, denoted by the capital G. ठीक है? This is called maximum useful available work. This is defined for the constant temperature and pressure. Okay. What is G? G is actually U plus, it is nothing. See, it is actually H minus Ts. It is H minus Ts. Okay. So we can write H as U plus PV minus Ts. As you know, what is the U? U is the energy required and is required to create a system. PV is the work done by the system for its existence, and Ts is basically basically heat received by the system. Okay, is it clear to you? Anji, is it clear to you? So in A is U minus Ts and G is U minus Ts plus PV. So this is the maximum useful available work. Gibbs free energy is the maximum useful available work. This is the in terms of availability, how much work we have, but out of which what maximum work is available for the work, what actually the work will be available. This is the amount U minus TS. Okay, that's why it is called maximum useful work. Maximum useful work. Okay, is it clear to you? Now, see, Helmholtz free energy A is equal to U minus TS. If I will write this equation in terms of differentiation, so dA is equal to du minus T ds minus s dt. Hanji. Clear? Is it clear to you? If we'll talk about the first law, then from the first law, we can say that my du is equal to del q minus del w. Del q minus del w. Okay? And for reversible process, I hope that you know this. For a reversible process, I can write del q as TDS. Okay? And I think you have covered in the classical thermodynamics this thing. Hanji, clear? Del q is equal to TDS. So if I put this, I will put these values in the dA equation, then dA will be du minus TDS minus SDT. What is the your du? Du is the del q minus del w. What is the del q? TDS. So at the place of this, I can write del q, which is TDS, minus del w minus TDS minus SDT. Minus SDT, right? TDS gets cancelled out to each other, and dA is equal to, as we already discussed about it, that dA is defined for the constant temperature. So at constant temperature, this term is also 0 for temperature constant. So what is the dA? dA will be minus del W. What is the value of dA? dA value will be minus del W. That's why it is called, dA is called work function. dA will be called work function. Okay? It is work function. Clear? Okay. We will talk about the Gibbs free energy. What is the G? G is equal to U, H plus H minus TS. H, I will put H is equal to U plus PV minus TS, right? This is the H. This is H minus TS. So I'll write in differential form dG is equal to du plus PdV plus VdP minus TDS minus SDT. Hanji. Right? Is it clear to you? So dG is equal to, okay, just write like this. No need to ऐसे करते हैं एक बार. It is U minus TS. U minus TS plus PV. U minus TS is my A. A plus, it is A plus PV. And dG is my dA plus PdV plus VdP, right? I write it like U minus TS is A plus PV. So G is equal to A plus PV. And after differentiation, dC is equal to dA plus PdV plus VdP, right? At constant pressure, dC is equal to what? It is my dA is my minus del W. At constant pressure is equal to 0. And plus it is PdV. It is PdV, right? So del G, so whatever the extra work you see here, whatever the extra work, maximum useful work you see here, that is this work PdV. This is the other work actually. This is the actually other work, right? Is it clear to you? So in the Gibbs free energy, this amount of work is extra as compared to the as compared to the Helmholtz free energy. Helmholtz free energy, right? So these four equations are the relation between the U, H, A, G are important actually. Okay, these relations are very important. So I hope that you are aware about these relations, but with the help of a diagram, just you can remember these relations. So that that diagram is called mnemonic diagram. What is the mnemonic diagram? Mnemonic diagram is this. This is U, this is your H, this is your A, and this is your G. See, A and G are the free energies. U and H are the different type of energy, internal energy and the enthalpy, right? Okay, this diagram is something like that. If you are going left to right, then you have to add PV, and if you are going from top to down, then you have to minus TS. Minus TS. Is it clear to you? Is it clear to you? हाँ जी बोलो. ठीक है, देखो. If I want H, then what is the H? H कैसे आएगा? You can going from U to H. So you have to go from left to right. So U plus PV. So by adding U plus PV, you are getting H. Okay. You want A. So how you want A? How you get the A? U minus TS, and you are reaching at the A. So what is the A? A is equal to U minus TS. Okay. If you want G, so from H to G, if you want G, then there are, you can say, two methods. Whether you are you can go from H to G, or whether you are go from A to G. If you are going from H to G, then what is the G? H minus TS. H minus TS. Okay, from A to G, what you need to do? You have to add A plus, if you are going here, so you have to add PV. So A plus PV is equal to G, है ना? This equation. Is it clear to you? हाँ जी बोलो. Is it clear to you guys? बोलिए. So these are the four equations. H is equal to U plus PV, A is equal to U minus TS, or G is equal to H minus TS. These are the important equations. Bolo. Is it clear to you or not? So to remember these equations, you can remember this mnemonic diagram also. So by adding this, by getting any value, you can go here or you can go down. U plus PV is equal to H, U minus TS is equal to A. Okay, for G, you can H minus TS is G, or A plus PV is equal to G. So these are the four equations. These are the four equations which are very, very important. So these relations are very, very important. Whatever you can say variation we will see in the future, that variation will be based upon these equations. The relation between the H, relation between the U, H, A, G. So you should remember these relations on your tips, guys. ये ऐसे याद होने चाहिए. Just if anybody asks about the relation, just this is very, very, you can say, चुटकी में याद रहना चाहिए. Right? Is it clear to you? Correct? और you can, मैं कैसे याद रखता था? I do not use this mnemonic diagram. It's your convenience. मैं ऐसे कुछ याद रख लेता था. That I know it is U, H and A and G. This is the chronology, है ना? Okay, so first is my U, फिर second is H, third is A, fourth is G, है ना? In this way we define this. Okay, I know the U. What is the D? Del Q minus del W. Okay, I know this. H is basically coming from this U plus PV. A is coming from, A is related to U and G is related to H. ठीक है? This is the basically free energy. I'm just only telling you. I'm not forcing you that remember these terms like this. किसी भी मेथड से आपको याद है, well and good. Okay, go with it. Right? Okay, so in the free energy, A is on the upper hand. So in the upper hand, it is U. So it is U minus Ts and it is H minus Ts. Okay, this is my method. This is the thing which I used to follow. So, but it's your choice. I'll say remember this numeric diagram. This is more reliable. Maybe you forget the chronology, you forget the order, you know, it may be possible, but mnemonic diagram is good. But if, because you have to solve so much questions on it, so believe me, you just know these things in your these things will be in your unconscious mind, and there is no need to put any efforts to remember these equations actually, because you have to do so much work on it. You have to use you can say so many times that there is no need to put any effort to remember these equations. So okay, so this is it for the today's class, guys. Okay, and I hope that you learn something, and let's take in the next class we will discuss further all these things. And ठीक है, किया ने मुझे topics भेज दिए, based upon that wherever required I add the topics. Okay, हाँ जी. So बताइए, समझ में आया आपको? Guys, tell me that you guys समझ में आई चीजें या नहीं आई? Let me know. See, solution thermodynamics is a kind of a very different subject actually. I'll say it is a very different subject. It contains the thermodynamics, but explanations are very different. ठीक है? I cannot say that this is the difficult. I also cannot say this is a very easy chapter syllabus. No. If you are actually, आपको मैं स्ट्रैटेजी बताऊं सॉल्यूशन थर्मोडायनेमिक्स के लिए. You should be very clear about the small things. You should be very clear about the fundamentals. ठीक है? You should be clear about that. If you are very clear about that, then only you can do the solution thermodynamic question. Otherwise, you will see in the second or third chapter, everything will be seems very similar. सब कुछ एक जैसा लगना शुरू हो जाएगा. ठीक है? So to avoid that situation, just revise it revise this. You can say सबसे basic चीज भी है ना, वो भी revise कीजिए इसकी. So whatever we discussed here, just revise that. This is the only method to you can say solve the solution thermodynamic questions. That's it. Okay, thank you so much. मिलते हैं फिर next class में. ठीक है, चलिए, thank you so much. Bye bye, take care. You got this PDF after the class, and let's meet in the next class. Just revise it, guys, and if you have any problem, let's discuss in the next class. ठीक है, and तब तक के लिए thank you so much, and bye bye and take care. Okay, bye. ओके ओके बेटा, हाँ जी, ठीक है, ओके.